The rapid adoption of command-line LLM coding agents introduced a new data problem. They generate massive, continuous streams of output data that freeze execution. Running one agent is manageable, but tasking 5 or more of these autonomous agents concurrently breaks down the developer's ability to operate. Each agent requires its own context, its own process, and its own screen real estate. Standard terminal multiplexers were engineered strictly for sequential human input. A user types a command, waits for an output, and moves to the next task. They were not designed to host parallel machine execution. This creates a specific cognitive failure mode. When an agent stalls, waiting for human input or an API response, that pause gets buried deep within thousands of lines of hidden terminal pane scrollback. The inability to effectively track agent state forces developers to actively tab through identical black boxes, manually hunting for stalled processes or silent errors. The tools meant to abstract away manual coding instead create a tracking bottleneck. Legacy terminal architectures cap the operational limit of autonomous AI workflows. The software industry's default reaction to this tracking problem is to wrap command-line agents in electron-based GUI orchestrators. Embedding an entire Chromium instance to render text introduces severe performance penalties. Running a heavy web framework IDE drains system memory and spikes CPU usage before a single line of code is evaluated. These GUI tools also force developers into rigid, opinionated workflows. The orchestrator dictates exactly how agents must be prompted, configured, and deployed. But there is a structural alternative: cmux PanEcho. PanEcho is a structurally optimized macOS terminal. It embeds UI affordances and inter-process communication sockets directly into a native environment. Scaling multi-agent workflows requires evolving the core primitives of the terminal itself, rather than abandoning it for a bloated, prescriptive GUI. Managing autonomous code generation begins with raw rendering performance. When multiple agents are writing thousands of tokens per second, the interface cannot drop frames or lag behind the execution. Achieving this requires the intentional removal of web views. PanEcho is built as a Swift and AppKit native macOS wrapper. Underneath that native shell sits the foundational rendering engine, libghosty. This architecture locks directly into the machine's hardware layer. By offloading character drawing to the GPU, the system processes the massive token throughput of parallel agent outputs with zero visual latency. Legacy web-based terminals choke on this volume of text, buffering output and delaying feedback. The native hardware profile keeps the UI highly responsive even under maximum load. Eliminating the visual rendering bottleneck is the prerequisite foundation for hosting dozens of concurrent AI agents on a single machine. Multi-agent sessions are complex and often outlast a single sitting. They must survive hardware restarts, sudden network drops, and app terminations. PanEcho actively serializes layout elements to solve this. It captures the exact state of your pane splits, working directories, and terminal scrollback, writing it directly to disk. Down in the local file system architecture, specific session hooks anchor to native session IDs. These hooks capture the unique identifiers of individual processes, tracking exactly which instance of Claude, Code, or Codex is running in which pane. Following a hard quit, the application reads the saved layout, reconstructs the precise window geometry, and automatically reconnects the agents to their specific processes. This serialization ensures that fragile, temporary processes function as reliable, asynchronous AI workflows. Standard terminals have a core UI problem. They treat all incoming text strings exactly the same, applying no hierarchy of importance. Agents and scripts emit standard terminal escape sequences, specifically OSC 9, 99, and 777, to communicate status. PanEcho actively parses these specific escape sequences to intercept the exact execution blocks where an autonomous agent pauses and requires human intervention. The application translates that passive text signal into an immediate UI update, drawing a glowing blue visual ring around the stalled terminal pane. It also projects underlying state metadata, such as Git branches, active ports, and the specific text of the notification, directly onto the vertical sidebar tabs. A single keyboard shortcut snaps the developer's cursor directly to the oldest unread node, bypassing the need to visually scan the interface. Translating terminal outputs into a visual hierarchy removes the friction of manual state tracking. There is a critical limitation when text-only CLI agents attempt to author front-end web applications. They are blind to the visual output. To write accurate UI code, these agents require a closed-loop verification system to see the actual rendered results of their commits. PanEcho solves this by co-locating a native, fully scriptable web browser directly within a horizontal terminal split. A Unix socket acts as a secure, high-speed bridge between the CLI agent and this integrated browser environment. The agent pings the socket, requesting a full snapshot of the browser's DOM accessibility tree. Utilizing the returned element references, the agent can autonomously fill forms, trigger clicks, or evaluate JavaScript natively against the live page. In legacy workflows, the agent halts and waits for a human developer to manually confirm that a visual change was successful. A programmatic, socket-driven web environment closes the feedback loop, enabling agents to verify their own UI changes independently. Fast rendering, awareness routing, and integrated browser testing operate together as a single unified model. Executing parallel tasks, like deploying Claude Code in teammate mode, becomes structurally coherent. Developers can visually track multiple subagents, monitor active web browsers, and audit precise Git metadata simultaneously across their splits. The core philosophy here is restraint. PanEcho acts strictly as an unopinionated primitive, not a prescribed solution. Engineering teams can leverage the Unix sockets and the command line interface to script completely custom orchestration loops that fit their specific codebase. The optimal future of AI orchestration will not come from closed GUI products. It will come from engineers building their own highly customized terminal workflows.